guys, it's day 2 of Unit 6. We're going to discover radians on our unit circle plate. Make sure you take out your plate, look at the plate that you'll see right now, and make sure that yours is complete and correct and looks just like mine. Push the pause button if you need to make sure that everything's labeled correctly before we proceed. Okay, so we only have one definition today, but it's huge, and so make sure you get it, you pay attention to it, and you see how we measure it. Our word of the day is radian. A radian is the measure of an angle in which the length of the radius is equal to the length of the arc. Think about how we've always measured angles, and that's been in degrees. This is just another unit of measure, kind of like transferring from inches to centimeters. Measuring the same thing, we're still measuring angles. Now we just have a different way to name them. So get your definition down. Again, a radian is the measure of an angle in which the length of the radius is equal to the length of the arc. We're writing our definitions on the back of our plate. And then flip your plate over and see what happens next. Okay, so in your bag, I gave you a piece of string. You're going to want to flip your paper over, your paper plate over, and get your string out, and some kind of a marker or dark colored pencil that you can make a mark on the string that it will show up. What we're going to do is measure the length of our radius using our string. A reminder that a radius is the length from a center of a circle out to the edge of a circle. So put the end of your string on the center, the origin, straighten it out along your initial ray, and make a nice dark mark at the point 1, 0. I used a black Sharpie. It doesn't have to be a Sharpie, but just make sure it's something that you'll be able to see as we continue today. So what I've just done is measured my radius. I measured on my string that length of the radius. Now, because we can't really measure curves well, we use the string and we wrap it around our unit circle to continue to measure that radius length. So notice I wrap the string, put one end on the point 1, 0, and wrap the string and make a mark where I see my radius length mark. Again, keeping in mind the whole time that a radian is when the radius equals the arc. So then continue marking around your unit circle. Take the end of the string, put it on the previous mark, and make a second mark for a second radian. And move all the way around your circle doing the same thing. Watch carefully on the video. Your marks won't be exactly the same as mine, but they should be close to the same as mine. The more careful you've measured, the more you'll understand how we're going to use this as we continue. And notice near our starting point there's a little bit of extra space. That's okay. We don't want to overlap. We're just curious about how many radians there are in that entire circumference. So I took my radius length, measured it on a string, measured an arc of the same length with the string. So I've just created an angle whose measure is 1 radian. Again, it's just another way of measuring an angle. It's just another unit. Inches to centimeters, degrees to radians. It's the same idea. Take your 1 radian angle and label it on your plate, like I did. And now I want you to think about how many radius lengths are there in the circumference of a circle? How many radian markings do we have all the way around our circle? And if you count around, you'll notice there are 6. There are 6 radians, and a little bit more, right? We didn't get exactly 6. In our circumference. Well, if we fold our plate in half, we now have half of a circle, half of a circumference. Let's look at quadrants 1 and 2 and count radius lengths, or radians. There's 1, 2, 3, and a little bit more. Now, luckily for us, there is a really famous number that represents 3 and a little bit more. 3 and a little bit more. 3.141592653 is pi. So 180 degrees is equal to pi radians, because we had 3 radiuses and a little bit more. Label it, know it well. That is our base for everything we're going to do with degree and radian conversions from here on out. Open your plate back up, and now let's think about our other points on our unit circle. First of all, remember last time we talked about how each point needed 3 names, and now this 180 has 3 names. We have a degree name, 180, we have a coordinate name, -10, and we have a radian name, pi. We need to do that with all of our points. So if you think about 90, 90 is half of 80. So pi halves is half of pi. 90 degrees then is pi halves radians. Leave that as a fraction. No decimals allowed. So there are 90 degrees, 3 names. Pi halves radians, 90 degrees, and 0, 1. Since math is consistent, we can work our way around the unit circle. If we go down to 270, well, 270 is 3 times 90. And if I count in pi halves, I'd have 1 pi halves, 2 pi halves, and 3 pi halves. So 270 degrees is 3 pi halves, 3 times 90 radians. Now that point has its 3 names, 0, -1, 270, and 3 pi halves. Again, leave those in fractions. Use the symbol for pi. I just can't do that with the video text. 0, well, 0 times 0 is 0. That's kind of a no-brainer. 0 degrees is 0 pi radians. That's a quick and easy. And our last point that we have right now is 360 degrees. Well, 360 degrees is twice 180. It's a full circumference, and 180 was half of a circumference. So since 360 is 2 times 180, 360 is 2 times pi, or 2 pi radians. Now this is our special point that has more than 3 names, but it does have degree names, radian names, and a coordinate name. Make sure you have them labeled. And that's it for the first part of the video. You need to take time to make sure that your plate is complete and correct at this point. When you're ready, you will need to go to the next video. We do have 2 must-do videos for tonight. So check all of your points. Make sure they have their 3 names, coordinate, degree, and radians, and that they're the same as mine. And really think about how they're all multiples or divisions of each other. That will be this case forever.